All right, we're going to look at some more instant methods that are built in with the string class. What we can do is we have some booleans that return values of true or false. We have some integer values that let us do comparisons. And we'll look at for equals. So if a string is equal to another string, we get a truth. If we look for equality without case, we have equals ignore case. And compared to, we have an integer that's 0, greater than 0, equal to 0, or less than 0 to indicate whether the string is greater than, equal to, or less than the string it's being compared to. And we'll play with that to see what the output is on it. We can use a compare to ignoring case. We can use starts with, which returns true if the string starts with a particular prefix. And we can use ends with to see if it ends with a particular suffix. So we can use ways of getting certain parts of a string. So let's look at some of these comparisons in our sandbox. So come back to Eclipse. And I already have the input for, let's get an input here, and we'll use next to compare 3 words that we'll type in, or actually 2. We'll look at 2 inputs, and we'll look at the comparisons. So what we'll want to do is we're going to print the results of the comparisons. So the first thing that we're going to do is we're going to take message 1, and we'll say equals, and we're going to compare it to message 2. Did I message 1? Oh, input next. I need input next here. There we go. And print F. I'm going to make this a print line. So we're inputting 2 words separated by spaces, and we're going to see if they're equal to each other. And we'll look at what equality looks like. So I said 2 words, so we'll do number 2 or 2 and 2. That's true because the 2 words were equal, character for character. We'll rerun this here. And we'll do 2 and 2. They're false because they're not equal character to character. So this ability to compare strings, it has to be identical for every character. But we can do equals with ignore case. So let's add equals, but we'll put in the ignore case option. And so now 2 and 2 are equal. 2 and 2 are equal. But 2 and 2 are not equal. So we have some powerful instance methods that we can call that will run comparisons on our strings for us. Let's look at compare, where we'll get an equal to or less than value, and then we'll also compare to ignoring case. So, right, we've looked at equals and equals ignore case. Now we're going to look at compare to and compare to ignoring case. So again, I'm just using my sandbox to run some things. So compare to, if I can spell today. So we'll do 2 compared to 3. And so 3 gives me a positive integer. So let's look at what this is telling us. come back here and say, returns an integer greater than 0, equal to 0, less than 0 to indicate whether the string is greater than or equal to or less than string 1. And so if we go back and look at the input I did here, 2 alphabetically is later or greater than numerically than 3. And let's try 2 and 2. Well, the capital letters were earlier in the integers than the lowercase letters, so this capital T has a lower numerical value than TWO. So we get a comparison that shows a hint at ordering. Let's do 2 and 2. The number 2 in the ASCII table came before the letters. And so we have this comparison that looks at the ASCII values as a way of sorting strings. And let's also ignore case. And so now if I compare 2 and 3, 2 comes later alphabetically than 3. And so it's a larger numerical value. And we want starts with and ends with. There are some prefixes that we want to see if they're within the string. So let's come over here and we'll do starts with. So does these start with the, which is true. That prefix the is in the beginning of these. Let's run it again. And let's see if my first input, does it start with the second input? So let's say starling and star is true. But encounter and incur is false. So it looks for this pattern and sees if it is the beginning of the other string. And let's try ends with. So hither, does it end with hither? Yes. Computer, does it end with ER? Yes. So we have ways that we can check for, well, let's do a false one too. 3 and here. False. Even though it has those letters, they are not in that order. And so we have ways that we can look for parts of strings. This is a good way of really processing data to look at if it's entered in a format where we can section off substrings. And of course, I hate this about this program. Let me look at these examples. I wanted to do starts with and ends with. That's where I messed up. My apologies. And I'll redo some of the examples I did here. So starts with, I did starling and star, which is true. These and the, which is true. These does start with the. And let's look at a false. These and he, which is false, because it does not exactly start with that letter combination. And again, with ends with, computer ER. Right, so I'm already thinking we can make grammatical rules. We can look for things that look to see if it's an ER ending word. Um, let's look at there and here, which is not correct. And so we have the beginning of processing that we can work our way through strings looking for patterns. Now, one of the things we can do in trying to find patterns without using specific ends or beginnings is we can look for what are called substrings, which are strings inside of strings. So if we enter whole sentences, can we find word boundaries? Can we find certain parts of the string? And we use the indexings to create these substrings. So if we look at this example here, it has the welcome to Java and substring begin index, and it can go from begin to end index. So if I just put a begin index like message.substring11, it starts at index 11 and grabs all the characters to the end of the string. But if I use a begin comma end index like 011, it grabs everything up to the end index -1. So this is really saying start at 0 and grab 11 characters. So I technically wouldn't say end index, I would say number of characters if I were writing the documentation for this. And we can also search for an individual character inside of a string. So you can get the index of a particular character. This will return the first occurrence of that character in the string. If it does not find the character in the string, it will return a -1. You can have it start from a particular index value and it will return after that. You can search for an entire string. So if you give it a character, it looks for the individual letter. If you give it an entire string, it looks for the occurrence of the string. The last occurrence goes the opposite. It searches from the back forward, and you can also give it a character or a string. And both of these will return a -1 if nothing matches. So here you can find the first name and the last name by using the index of the space. So if someone enters a full name, you look for the index of the space, and then in the first name gets 0 up to that index, and then the last name starts from that index +1. So let's actually work on this. Let's give an input for someone to enter their first and last name, and then we'll break it into the two parts. So we'll do that over here in our sandbox. Let me see. Okay, it did switch over to Eclipse this time. And I'll come over here. So what we're going to do is we're going to take a next line. And I think we're going to make 3 string variables. One will be full name, first name, and last name. And so enter full name. And yes, I know I'm ignoring middle name, but we'll make it work here. So we'll take the full name using a next line. So we're not, remember, next searches on white space, and next line takes up to the enter key. And so that means that our we'll want to find our integer index equals s index of, and we're going to search for a space. And what do I have wrong here? Oh, it's not S, it's full name. There we go. So we're using this instance method. We're searching for the first space, and that first space divides our full name into two parts. And so the first name will equal the substring. Am I still in Eclipse? Yes. And so we want to grab a substring. And we want to go to the index. But we want to start at 0. So let's see here, 0, comma, index. So this will go from 0 up into the kth letter, which is the one right before the space. And then last name equals full name, and substring, we're going to start from index +1 to get to the other side of the space. And I think that'll be right. Let's use a printf to work out what we have. And so let's make a fancy little form here. We'll say first name. We'll put a place for the first string. We'll make a line. And again, I'm going to separate this. And then last name. We'll hold a marker for the string, and we'll print a new line. And so we're going to need to feed it two values. First name will be the first value that goes into the first position holder, and last name will be the value that goes into the last position holder. So let's see if this works. Enter the full name. And notice it separates nicely for me here. In fact, if I wanted to neaten this up so it was organized more, I think what I might do is insert a tab to line these things up. Let's see if that cleans up my output a little bit. And noticing the tabbing has those line up neatly for me. I could play with some formatting to line up the first name, last name so that the semicolons came together. But by using a tab stop to move over, I have lined up those inputs and outputs. So we have some ability to slice and dice our way through these characters, and we can play with the different conventions that we have when processing text. We actually have the beginning of some very powerful tools here. Let's continue looking at what we have inside of our string features here. You can convert between a string and a numerical value. There are parsers that will take a string, and if it's an integer, turn it numerically into an integer. And the same with doubles. And so you take the string value, parse int, and integer comes back out. And this is what the scanner object was doing for us. The scanner object has a lot of these methods built in, but Java also has some native values, native methods that can be used to parse strings into other variable types. And so we can use this to work our way through different value processing. And what we're going to do here is we're going to look at a program that converts a hexadecimal digit into a decimal value. And so hexadecimal digits have a particular format. And what we're going to do is we're going to generate the program to